Okay, for question number 2 is synthesis of triaglycerols. The first that we do is synthesis of phosphatide. The phosphatide can be produced from glycerol 3-phosphate. Okay, the first type is glycerol 3-phosphate acyl transferase catalyzed esterification at C number 1. Produce 1-acyl glycerol 3-phosphate. Like this reaction. From glycerol 3-phosphate become 1-acyl glycerol 3-phosphate produce HSCoA. The next step is 1-acyl glycerol 3-phosphate acyl transferase catalyzed esterification at C number 2. Produce phosphatide like this reaction. From 1-acyl glycerol 3-phosphate become phosphatide produce HSCoA. So in reaction synthesis of phosphatide produce 2HSCoA.
Okay friend, I want to continue explain about how to synthesize of triacylglycerol. Before that, my friend have explained you how to synthesize of phosphatidate. Phosphatidate is using to synthesize of triacylglycerol. The formation of triacylglycerol from phosphatidate begin with a dephosphorylation catalyzed by phosphatidate phosphatase. The product is 1.2 diacyl glycerol and release 1 ohm of phosphate. The next indirectly 1.2 diacylglycerol that can be directly acetylate to form triacylglycerol. With diacylglycerol acyl transferase and release coenzyme ASH. 1.2 diacylglycerol alternatively can be reacted with CDP choline and CDP ethanolamine. To synthesize of phosphatidyl choline and phosphatidyl ethanolamine. The process will be explained in the next question. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Next is glycerophospholipid synthesis. This is the structure of glycerophospholipid. There is a glycogen backbone here. This is the C number 1, C number 2, and C number 3. In C number 1 and C number 2, there are fatty acids that bind it. And C number 3, there is a phosphate group and a polar head group that symbolized as X. It may be an amino alcohol or etc. Glycerophospholipid. Actually, the first step is same with 3-acylglycerol for synthesis. It is started with the phosphatidate formation. The first reaction is start with the reduction reaction of dihydroxyacetone with help by glycerol 3-phosphate dehydrogenase as catalyzed to form glycerol 3-phosphate. Let's see the glycerol 3-phosphate here. In C number 1 and C number 2, the functional group is hydroxy. But if we want to make a glycerophospholipid in C number 1 and C number 2, the functional group is ester. So, glycerol 3-phosphate acetyltransferase will catalyze the esterification in C number 1 to form 1-acylglycerol 3-phosphate. First, the O here will protonate it, so the charge is positive. Then the O here will attach the carbonyl. Because the O here will have 3 legs, it will release the H. And then the C here, because it have 5 legs, it will release the SCOA. And then it will form 1-acylglycerol 3-phosphate here. And the C number 1, the hydroxy functional group has been changed into ester group, CH2OCOR1. But in the C number 2, the functional group is still hydroxy, so we change again with catalyzed of 1-acylglycerol 3-phosphate acetyltransferase, and the same step with before. The O here will protonate it, and O in the C number 2 will attach C carbonyl, and then because the O have 3 legs, it will release H, and the C have 5 legs, it will release SCOA, and then the phosphatidate formed. We can see in the C number 1 and C number 2, the functional group are esters. The difference of synthesized 3-acylglycerol and glycerophospholipid is in the reaction after 1.2 diacylglycerol formed here by the phosphorylation of phospholipid that catalyzed by phosphatidate phosphatase that will release the phosphate here and form again the alcohol or hydroxy here. In the 3-acylglycerol synthesis, the next step after 1,2-diacylglycerol form is still add fatty acyl-CoA to the C number 3. But in glycerophospholipid, the next step is reacting 1,2-diacylglycerol with nucleotide alcohol derivative, such as CDP choline or CDP ethanolamine. The nucleotide alcohol derivatives or CDP choline and CDP ethanolamine is formed by the reaction by CTP with alcohol phosphate. The alcohol phosphate here has 1 phosphate group and the CTP has 3 phosphate group, and it will form CDP alcohol and release 2 phosphate inorganic. Next step is reacting 1,2-diacylglycerol with CDP choline. Here the phosphate group here will attach O in the C number 3 here, and then H will release because the O has 3 legs. P here will cut its bond with O above because the leg is 6, so a CMP will release. It helped by phosphocholine transferase. Then the product is phosphatidylcholine. Another way to form phosphatidylcholine is by reacting CDP ethanolamine with help by phosphoethanolamine transferase that will release CMP also. The same step will done and will produce phosphatidylethanolamine. But because this is NH3+, so methylation reaction will occur by changing H of H that bind with N with methyl group, and it will form phosphatidylcholine. The phosphatidylcholine are commonly found in cell membrane. This is a neutral phospholipid. But the phosphatidate can also be a precursor or the founder of a compound formation of acidic phospholipid. But first, phosphatidate will be activated by react with CTP. As we know, CTP has 3 phosphate. One of phosphate will attach here and then will release 2 phosphate by help with CTP phosphatidate cytidinil transferase to form CDP deacylglycerol. Here, CDP deacylglycerol will react with serine that catalyzed by phosphatidylserine synthase. This is the structure of serine. The O here will attach with the P here. Because the P has 6 legs, it will release the phosphate here or CMP, and the phosphatidylserine is formed. This reaction is for some bacteria, but most of eukaryotes use different pathway to synthesize phosphatidylserine. The phosphatidylserine is formed by phosphatidylethanolamine from the reaction that we learned before, with reacting with serine by helping of phosphatidylethanolamine serine transferase, and it will release the ethanolamine here to form phosphatidylserine. The phosphatidylserine also can be phosphatidylethanolamine again by using phosphatidylserine decarboxylase. Back again to the previous slide. In prokaryote and eukaryote, same step will occur by adding inositol. Inositol will bind with phosphate and will release CMP, and phosphatidylinositol will form.